Hello, everybody. Welcome to the Deep Space Exploration Society Science meeting, our, our regularly monthly review of sciences. And today we have the Edge of Space Sciences on review. So Doug Lieber is a member of the Edge of Space Sciences group, and I'll let him introduce our guest speaker tonight.
Thank you, Paul. Mike Pappas should take credit, I guess, for uh, bringing me into Edge of Space Sciences. Soon after I got my tech license, I dropped into Rocky Mountain Ham University presentation on mobile vehicle power for powering your powering the radios in mobile vehicles. Mike was presenting. And it was a fascinating talk. But that's when I heard about these balloons going on. And then I learned about Edge of Space Sciences. That was 2 years ago. And since then, I've dived in head first and appreciated the wonderful members of that group, of which Michael is a stellar member. He is alpha in literally the leader of the flight tracking teams for Edge of Space Sciences. So I wanted to thank him, and I was delighted to hear that he's giving a presentation for us tonight. Now, tonight you're going to talk mostly on our main activity, which is weather balloons. But Michael, I wanted to say that there's been some recent interest in pico balloons within our group, and that perhaps that's something that we might do together. Our organizations might do together down the line. Are you going to talk at all about pico balloons tonight?
Well, Doug, I will be happy to do that. You're going to remind me to talk about it. So
Yeah, will do.
it's certainly one of our more interesting projects. And uh, Jim Langstead is the Pico balloon guru, and I think we've got one that's made 12 laps of the Earth at this point. So
Yes.
I haven't. I've been out of pocket for the last week. Last week Monday I flew to Nashville, and then from Nashville to New York City, and then from New York City to LA, and then back today. And I think I'm coming down with a bit of a cold, so you have to excuse me if I'm
Okay.
sounding a little raspy and grasping for Kleenex. But with that, I'm going to go ahead and start if everybody's all right with that. We good?
Excellent.
Great. So thank you for the opportunity to uh, chat about space sciences. Doug is one of our latest converts. You know, we try to put the hooks in people and drag them in, and Doug's been great, and that was a wonderful introduction. I really appreciate it. Um, let's see if I can figure out how to get this to advance. Let's try that button. Nope, didn't like that. That one worked. We're a nonprofit organization, was formed in 1990. Uh, Basically, you know, we get payloads to typically above 99% of the Earth's atmosphere. Virtually all of our clients are schools, and the prod, most of this is sponsored through something called the Space Grant Consortium, which is a NASA program to try to get kids uh, interested in STEM projects so that we can brew up our own engineering people instead of having to import them somewhere else. So, you know, basically the operations are pretty simple. It's all the details that get to be complex. So, all of our flights are coordinated through the FAA, and we have a Part 101 waiver, and the Part 101 waiver is renegotiated every year with the FAA, and we have a crew that does that FAA interface, and they've been doing it for 30 some years. But we feed tracking data in real time to the FAA, and they basically route aircraft around us. Additionally, we carry we carry ADS-B beacons on those, which communicate directly with aircraft and say, hey, we're a balloon and we can't move, which means that you're going to have to move around us. We typically fly a pair of APRS beacons on every balloon. We do that because before we did that, we had problems where balloon beacons or APRS would quit, and then it became a real issue trying to find things. So currently, we fly a pair of APRS beacons on them, and to make sure that we get things back. Typically, ascents take about 90 minutes or so. Typically, we end up somewhere between 80 and 100K altitude before the balloon itself pops. The balloons are made out of latex. We fill them with hydrogen. We've been running hydrogen now for about 15 years because helium became so expensive that it was putting the cost of doing a balloon flight out of reach of most of our customers. So we made the conversion to hydrogen, and of course that means there's a no smoking light that's on, and we had to change a couple of procedures, but it's been very safe and very cost effective. On the way up, we collect all the data for the ascent, and we have a couple of very smart people that have generated some amazing software that allows us to look at the ascent data and use that to create a prediction as to where things are going to land. And the accuracy of that system is remarkable. We could be 40, 50, 60 miles downrange where we can launch it. It typically will be under a mile, sometimes even less, where the balloon is landing. We'll be standing by the side of the road with 150 students going, it's going to land right in that cornfield. And it typically does. One day I sent one of my track and recovery people down on the road. I said, drive about 1.25 miles down the road, stop the car and open up the back door on the driver's side. The payload's going to fly right into the back door. And I was only off by about 25 yards. And considering we're 45 miles downrange, it was pretty good shooting. In the old days, before we had all this high-tech stuff, if we were within 10 miles of where the payloads landed, that was considered to be good. Now, as you probably guess, when you're at 100,000 feet, there isn't a lot of atmosphere there. So we're going to drop somewhere in the range of 40,000 feet or so before the parachute actually is going to have enough atmospheric density to open up and start slowing the payload down. Now, that assumes, and there's a big assumption here, that assumes that during the post-burst chaos, that the parachute didn't get entangled with things. And we have a whole system that releases the balloon once it detects a burst. And if that system doesn't quite work, or if the bottom of the payload string comes up and smacks the top of the payload strings and entangles the parachute, things can come down quite rapidly. But typically descents are about 45 minutes or so. Hang on, I've got a cough here for a second. Sorry, it's whatever. It's either a cold or this warm weather has started things to blossom and I'm having allergies. So it's about a 45-minute ride on the way down. Our telemetry systems are constantly getting the data off the balloons, and they're doing a bunch of algorithms working on that with a bunch of algorithms to determine our predicted landing. So the further down we get, the more accurate the predictions become. Okay, come on, we can do this. I know we can do it. So, once this thing's on the ground, we locate the payloads, we identify the landowners, we obtain landowners' permission to access. Because the world has changed since I started this, and I've been on USS flights since about 100, and we're coming up on 400 right now. We always send out notifications to all the local sheriff's department that we're going to be potentially landing in their county. We give them a whole list of phone numbers and contacts so that if people call going, oh man, there's like all these cars running around with all these antennas on it, that we get they know that we're out there, and it makes things better when landowners call 911 and go, there's all these weird people out here. As I mentioned, we get about a 45-minute descent, and then it's a hike in and recover once we get landowners' permission to access the location. All of the payloads, the tracking payloads, the APRS stuff, have got batteries in them for, I believe it's 4 or 5 days worth of running. So if something goes really sideways, and that's happened in the past, we'll get enough time on the APRS beacons and the direction finding beacons to go out and find it, assuming that we don't have telemetry that's pointing us in a general direction. Amateur radio is absolutely integral to this whole project. We couldn't do without it. Obviously, APRS is on 2 meters, and we do all of our voice traffic on 70 centimeters. And the reason we do that is so that we don't desense the APRS receivers in the vehicles with 2-meter traffic. A long time ago on a planet far, far and away in a different lifetime in another galaxy, we used to use VHF for both comms and APRS. The problem we ran into was we desensed so many packets that the prediction software, which was pretty crude at that time, got worse in terms of being able to come up with a prediction, which is why I said earlier, if we were within 10 miles, I thought we were doing a great job. Now I complain if we're greater than a mile away. We have a ground station which runs both analog and DMR radio comms. We're using SDR-based APRS receive systems. The ground station also provides iGating and FAA coordination. So they push APRS data to the FAA Denver TRACON, who then routes aircraft around where we're flying. And in the past, we've seen aircraft tracks that made nice maneuvers around where we were flying. As I mentioned earlier, our flight stringer runs a pair of redundant APRS beacons along with ADS-B, and the FAA has given us our own tail numbers for our balloons. And as I mentioned, we run redundant APRS beacons, and we've learned at some great cost that only having one beacon on there is never a good plan, and sometimes things quit. The tracking teams run analog and DMR radio comms, SDR-based APRS systems. I run a full iGate that's connected via 5G LTE modems, and Starlink is kind of the Earth comes to an end, kind of how do we get comms out of the middle of nowhere? That's our ground station van. That is that was donated to the club from Channel 4 KCNC, and that used to have a KU band uplink on the top of it, which was about 1,000 pounds of very top heavy weight, which took about 7 of us to get off the truck and into a dumpster. It was very nice of KCNC to donate that truck to us, because we used to do ground station on a card table set up in a parking lot. And in 20-degree weather, that was pretty chilly. So this is a very large step up for us. It's got an Onan 7-kilowatt gas-powered genset. It also has an Origen 5-kilowatt generator that's tied into the engine. So we've got a couple of different ways to power it all up. There's a lot of comms in the truck. And it also has Starlink and cellular data modems. And it can also receive ADS-B reception and upload flight radar 24 information. We also call the FAA. First off, we file an FAA, we're going to fly thing. That's usually a week out. And then we keep feeding them predictions based on weather. And then we call them up and tell them that we're going to launch. And off we go. Balloon fill. If any of you are familiar with the original MASH movie, the anesthesiologists were called gas passers. And we lovingly refer to our balloon fill team as the gas passing team. And those are some pictures of the balloon being filled. Gas passing, i.e. balloon filling, is pretty critical to our operation. And we have to be right on the numbers in terms of the amount of lift. Otherwise, everything goes out the window in terms of prediction, ascent rate, ultimate burst altitude are all pretty much dictated by the fill and how accurate the fill is. So if you look at the picture all the way on the right-hand side of your screen, you'll see there's like a black bag there that's attached to the neck of the balloon, and that has a precise amount of weight in it that's based on the weight of the payloads. And because students are putting these together and there may or may not be accurate weights for each of the payloads, we measure and weigh those payloads on site before we put the flight string together, just to make sure that we've got an accurate weight. Because without that lift being accurate, things can get unhappy. These are some pictures of some students' payloads, and you can see what those typically look like. It's foam core with foil tape on it that you buy from the HVAC store. And then there's a flight string. That orange string is a 500-pound test nylon rope that's run through the center of all those payloads. And you can see the students lined up at getting ready to launch, go out to where the balloon's going to be launching from. And on the far right side there is an image of our head of payload strings, Stephen Muir, getting organized with a payload. So what does this kind of look like? Well, there's a balloon, there's a cut down system. So we should mention that there's some issues here. We have the ability to cut away the balloon if we need to, if something has gone wrong. Underfill, high altitude winds outside of what we were expecting. One time, many years ago, we launched a balloon and it developed an ice coating through a series of clouds, which reduced its ascent rate and was putting a prediction somewhere in Nebraska. And we had to cut away the balloon to make sure that we could actually collect this thing up without being in, Grand Island, Nebraska. That's the release cut down system. There's a parachute, which I mentioned earlier. We have a top APRS beacon. The student payloads are next. Towards the bottom of the flight string is our ADS-B beacon, and then the bottom APRS beacon. And that flight string can be 50, 60, 70 feet long. The interesting thing about this is when the balloon bursts, it's not unusual for the bottom APRS beacon to come all the way up to the top and smack some of the student payloads. And we see this kind of damage regularly. Internally, we call this post-burst chaos. A fair amount of things can go wrong at that point. You can break antenna leads off from payloads, which may cause your APRS to disappear. Other damage can happen. We can entangle the balloon. It may not release, and that can cause problems with the parachute opening, which can reduce our ability to accurately figure out where the balloon's going to land. Tracking teams, there's typically 5 to 7 vehicles in a tracking team. We try to position downrange to track. We do a lot of communications. I think we're the biggest RMHAM DMR user out there. And we have a team that's developed an internal SDR tracking system. As I mentioned, we will transmit a cut down to a balloon if if necessary. So this is a prediction 24 hours before a flight that we were launching outside of Wiggins, Colorado. And it's going to end up just a bit outside of Burlington, Colorado. So you can see the flight path. The green side of that is ascent, and the red side is descent. Now, a couple of things here, because this prediction's done 24 hours in advance of actual flight. We know that this is not going to be accurate. We'll probably be within 10 or 15 miles of where we think this is going to land. And we're at 50 miles downrange from the launch site here in Burlington. And so what I would typically do would be to have our track and recovery team probably hold up at Siebert, Colorado, off from I-70, because it gives us the most options for if this thing comes up way short, how do we get to it, right? So a lot of the roads are not contiguous, north, south, east, west. So you've kind of think about, where you're going to go if something comes up short. On this flight, we were right around Bethune when that finally landed. The other thing is, you want to park somewhere where you've got a gas station, and a restroom and things like that. We would typically stage the students in those type of locations, waiting for things to develop. And as I mentioned, occasionally things go wrong. And if you look at this picture carefully, you'll see that we have a flight string that's landed across three-phase 7,200 volt distribution lines. And you can see that the local utility company has come out with one of their techs to get a bucket up there and get our payloads off their lines. And in the 20 some plus years I've done this, I think we've done about 4 or 5 wrap the payloads around power lines. The good news is we didn't cause any power outages for the local community. That's been known to happen in the past. We didn't burn up any students' payloads. That's also been known to happen in the past. As I mentioned earlier, we notify the local sheriff's department that we're going to be operating their jurisdiction. This is a typical email that goes out to this is the Cheyenne County Sheriff's Department. We've been doing this for so long that basically they know who we are and why we're out there. This got to be fun after the Chinese balloon project, if you all remember that fiasco when the Chinese decided to fly a balloon over the U.S. and then the Air Force went up and shot one of them down, and we were a little concerned because we were going to be doing some flights shortly after that. So I started calling around NORAD to try to get a hold of somebody. And I finally got a hold of somebody, and I said, hey, we're the balloon guys, and we got an FAA waiver, and we're going to go fly this weekend, and we'd really appreciate it if you didn't shoot down one of our balloons, because there's about 150 students that would be just heartbroken if all their payloads took a quick dive to the ground. And they started laughing, and I was somewhat miffed by that. And they said, oh, don't worry about it. We get all of your FAA notifications, so we know where you're flying, and we're looking at your ADSB information. And trust us, we're not going to spend $1 million on a surface or an air-to-air missile to shoot you guys out of the sky. At which point we all had a pretty good sized laugh on that call, and I invited them up to see the launch. But this is typically what we do, and you can see that we've got 2, 3, about 4 people from the Cheyenne County Sheriff's Department. They include the sheriff, the undersheriff, the patrol sergeant, and dispatch. So everybody's kind of on the same page. And you can see where we've got a predicted landing here, which is going to be near North-South County Road 44 and East-West Highway 385 in Cheyenne County. We give them the lat and the lawn. We give them the ground station phone number, flight coordinator, and my phone number if they have any questions. And this is typically what a recovery looks like in somebody's wheat field out in the middle of absolutely nowhere. And, we typically get if we can get landowner permission to get the students to walk in and collect up their stuff and, uh, and carry it out of there. And you can see that the landing on your right is a pretty typical way this stuff all hits the ground. Parachutes here and this stuff lays out in a line, just like that. We have a team that builds our own payloads. So we custom designed a release mechanism that's talked to by Bluetooth. We can do a cut down, as I mentioned earlier. We have a custom designed APRS beacon that we built. It uses an accelerometer to sense balloon burst. That arm's above 70,000 feet. So if there's some turbulence, it won't inadvertently release the balloon until you're above 70,000 feet. We have a 2-meter transmitter that we use. That was kind of a funny thing. I think I got a picture of it. And our ADSB is made by Yvonix, and that's at 1.09 gig. The bottom uses a Bionics-based APRS digipeater and beacon. Now, those are 1-watt radios that we run at 100 milliwatts because we need the battery life, and there's no free lunch in this. The more power output you have, the bigger the batteries have to be, which of course increases the weight. And if you want these things to run for 3 or 4 days, on the off chance that something goes seriously sideways, you've got to turn the power down to make that work. As I mentioned earlier, some occasionally things happen where the balloon doesn't release and it gets entangled with the parachute. That can cause everything that we know about where the thing is going to land to go right out the window. And instead of us having 45 minutes to put together a plan to get it, we'll have that thing on the ground in about 20. And that usually means that we're going to be short by 30 or 40 miles without too much trouble at all. So that's kind of what that looks like when things go sideways and the balloon doesn't release. We had a bunch of issues with the release mechanism, and our release mechanism team really worked hard on it. And we're pretty solid on getting releases now. And you can see on that picture towards the lower center left side there, we're in a cornfield. And that can always be a little challenging with students who show up wearing flip-flops. Not recommended. So this is some accelerometer data. Like I
Mike?
said, yes.
Yeah. Yeah, Doug and I actually a while ago had a conversation about I guess what you're calling post-burst chaos. And are you saying that you've pretty much solved that? Or are
No,
you still-
not at all. There's post-burst chaos is post-burst chaos.
so so have you correlated where the balloon ruptures first to what causes the most chaos?
No,
Like at the bottom or the top?
it's usually always the top. And if you look at the stuff that comes back from when we don't release the balloon, hang on, you'll see that right in this image here, that's the neck, and that's most all the balloon, and towards here is where it ruptured. They typically always do that. The top seems to always burst, but we don't have an accurate, unless we're lucky enough to actually see it visually pop. We don't, or have cameras.
Well, what is the weight of the latex balloon?
Well-
Just itself.
It's about 3 kilograms.
Okay, so I apologize for this kind of rat hole, but again, Doug and I talked about this for quite some time. So when it bursts at the top, is your theory that as the rubber snaps down, it's yanking the string up, and that's what gets everything entangled?
Yeah, there's several physicists who've been working on this for a while now, and I don't know exactly where they're at with it, but occasionally, like I said, we'll see that the bottom of the flight string, which is 50 or 60 feet down, will have come up and smacked the top of the flight string. And
Wow.
yeah, no, it's really interesting. Ascent rates are in the range of about 1,400 feet a minute, typically. It slows up a little bit as we get towards burst, but not appreciably. We're maybe down to 900 feet a minute, which is a pretty good clip. And when all that lift disappears instantly, things happen. So,
Okay. So you've got a momentum problem as well. Okay, I'll let you get back to your slideshow. So sorry about that.
Yeah,
Roger, go ahead.
Mike, this is Bill Miller. The other question I had was, do you have a way to burst the balloon? I was in this maybe 15 years ago, and some of the balloons they could burst. Do you have that capability?
No, all we can do is cut them loose.
So you expect them to calculate when they will burst, right?
Yeah, we've got some mathematical formulas that allow us to estimate burst relatively accurately. I mean, there's still a fair amount of fudge in this, you know, but there's some guys on the team that are really a lot smarter than I am, and I need to qualify this that I grew up in an age of slide rules, vacuum tubes, and punch cards. So a lot of this stuff is pretty interesting. Our track and recovery computers are all running Linux on industrial computers, and the software team wrote a whole UI and software package that does all this big lifting. But the quick answer is we just do a release to cut them away.
Okay, thanks.
But hey, more questions the better. I certainly enjoy those questions. It's a little different doing these presentations when there isn't, a live studio audience, as they used to say with the comedy shows.
Comment?
So,
Yeah.
so if you look at the accelerometer data here, you'll see the ascent, you'll see burst, and then you'll see everything get really interesting here, where acceleration can almost, well, it certainly has hit 3 Gs here right after burst, and then free fall, and then when things hit the ground. And we get this data for every flight. And it's all on our servers in a data center in Iron Mountain in downtown Denver. And if anybody's interested in it, I think we've got almost 100 flights worth of this data sitting there. As I mentioned, the release process, it's armed at 70,000 feet. There's an accelerometer in the top beacon that detects free fall after the burst, and then a release command is sent to release via Bluetooth LE link to release the balloon. A warble tone is transmitted over our 2-meter radio to indicate burst, and an APRS packet is sent out with a max altitude. This was all designed by some people who are really, really smart, and this generally works really well. Typical release time is less than a second after burst detection. So here's some of the release hardware. And like I said, we've got a team of folks that design this stuff and lay out the printed circuit boards, have the printed circuit boards all put together. They reflow solder this in some Frankenstein toaster oven that they've got set for Chernobyl temperatures. And off they go. And you can see, there's a serial port to configure this and an Atmel AVR processor that runs the whole thing. And there's a switching regulator for making power to get all this stuff work. And we have status LEDs that are visible from outside of the enclosure, the box that this is in, to make sure that thing is running correctly before we launch it. Because obviously, if the beacon isn't running correctly, you don't want to launch things. This is the TNC radio board, the top one. There's a thermocouple amplifier, barometer, accelerometer. There's a USB port for configuration, GPS. Yeah, there's a joke in there about a Navy ship buck boost switching regulator, GPS antenna, and there's that DRA 818V radio. And so we adopted this radio, and we had a real problem with it initially. It wasn't generating good APRS packets, and we came to realize that it was shipped in narrowband mode, and we had to firmware program it to run 25 kilohertz bandwidth. Otherwise, it just made a hash, no pun intended, out of the APRS packets. We also have had issues with GPS receivers. There's a real problem with a lot of GPS receivers that don't work above 35,000 feet. And the only way you know that is you have to fly them above 35,000 feet. And we've gotten burned. We had a flight, it was 220 something, where the bottom APRS payload didn't come to the show, didn't work. So somebody threw a Kenwood mobile radio with GPS in it in a bag, and we taped it to the flight string and launched it. The problem with the Kenwood radio was it was timed to turn off after 30 minutes. So 30 minutes into the flight, actually a little bit before that, we had 35,000 feet, and the top GPS receiver didn't like that. It stopped sending data. And then the Kenwood radio stopped. And then we were pretty much deaf, dumb, and blind. And it took a long time for that payload to come back. In fact, some farmer collected up in his combine and called us because there's a phone number on every payload. He said, this thing is all wrapped up in our combine. Can you guys come out here and get it? So the funny part is we sent a team out there and they collected it up, and the Kenwood radio powered right up and started sending packets the minute we turned it on. So it had spent 3 months out in some farmer's wheat field. And the battery was fine. The problem was we just didn't realize it had a 30-minute timeout on it, which of course meant that we were looking for this thing for quite a while. But like I said, we have a whole team that puts this stuff together, lays out the boards. That's KC0D right there. Mark Padden does all that work for us, and he's an absolute genius with it. And you can see this is multiple boards that are all put together here. There's a battery board. That's a couple of cells, and the flight string goes through this tube from top to bottom. GPS antenna is facing the sky, and off you go. Altitude versus temperature on descent. Again, we have lots and lots and lots of telemetry. It's kind of fun to see what happens. Outside temperature, inside temperature, external one-wire temperature, and based on time and temperature, pretty much we don't need to internally heat these. There's just enough thermal mass in there to keep everything running through a typical flight on its way back down. Tracking tech. So about 4 or 5 years ago, we had a team that started developing a new track software for us. Before that, we were using a Windows-based application that a member had written. It was somewhat limited. It did not like losing packets. It wasn't particularly reliable, and it couldn't handle more than 1 or 2 balloons at a time. The primary features of what we're currently running are software-based, no traditional radio, i.e. it runs SDRs. And it can simultaneously receive APRS packets on multiple frequencies. It's using OpenStreetMaps, and it gives us dynamic landing predictions. Lightweight user interface leverages a web browser. So we've had, you can basically run this thing on a smartphone. Receive only, nothing transmitted or uploaded to the internet except for folks like myself and some other people who have valid ham call signs and are doing iGate and RF beaconing. So this is kind of what it looks like. There's a small industrial computer here with a i5 in it. It's not particularly heavy. Some sort of GPS puck, an antenna to get 2 meters, and a new electric SDR that runs all of this. This is what the web interface looks like. So we're in this flight, we're looking at 5 APRS frequencies simultaneously. It's saying the GNU radio status is good, gives us the information on the SDR. It tells us that it's eye gating. We're not beaconing on this one. And here's a bunch of other data. It collects up air density, temperature, and pressure. It tells us where all this stuff is, and off we go. Now, here's some of the fun stuff. We get an instrument panel on every flight, right? So it tells us in the upper left-hand corner we're at 77,000 feet. We're going up at 844 feet a minute. It's just a little slow. We typically want to be at about 1,000. It's showing us its speed and its heading. It gives us a list of most recent position packets, which is kind of interesting because if something goes sideways, we want to know how long it's been since we've heard from a various beacon. It's showing us EOSS 13 and EOSS 12. They've been launched separately. There's a difference here of 20,000 feet. Here is our predicted flight path. And this is going to come down and make a turn, which of course is always fun. And off we go. So this is descending. And you can see here that these are predicted landing locations. It's showing us where the trackers are in relationship to the landing spots. This was off from Highway 36 on this flight. This was 288 and 287. You can click on this and it'll give you the data for either one of those. If we have a 3 flight, you'll have 3 of the balloons listed here. This is showing the original predict and the actual landing. And you can see here, it's not too far off, but as I mentioned, this prediction's done 24 hours before the actual launch, so it will typically be short from where we predict it. Some things that we're working on as part of this. Sorry, I'm mopping up a runny nose here. The brainiacs are working at self-aware beacons and advanced mapping. We've been running Google Earth Pro, and if you've got enough LTE coverage, or now with Starlink, you can get that to happen because Google Earth Pro loads that dynamically. We've been testing Raspberry Pi CM5 implementation, which is very lightweight. We've got the software down to a relatively easy lift. High performance SDR. So we're currently working with a program that allows us to digest the whole 2-meter band and turn that into multicast IP stream using some open source software that Phil Karn put together, KA9Q. Phil did 40 years at Bell Labs and then moved over to Qualcomm and designed a whole series of LTE modems for all the cellular phone manufacturers. A real bright guy. And for the truck, my truck, it's advantageous to turn the whole 2-meter band into multicast I and Q, because then I can feed it to multiple tracking computers, and that way we can beta test things without having a whole pile of different antennas on the roof of the truck. As one of our guys says, it's the endless pursuit of decimal dust, which of course is always humorous. But if you've got any spare time on your hands, we want you. So There are teams here that do customer relationships and ground station and launch teams and our gas passers and tracking teams and FAA interfacing and technologies and club leadership and website management and everything in between. On your right's a photo taken by one of the student payloads that had a camera looking up, which is kind of a unique image there. And there's our president and vice president and how to contact them. I'll give this to you guys in a PDF format. You can send it out. Questions? Wow, nobody's got any questions tonight.
Well, our next launch will be April 4th, and that's on the EOSS.org website.
And
that
well, yeah, we have 3 flights in a row. It's the 4th, the weekend after that, and the weekend after that. So in April, we're going to do 3 flights. And in May, we're going to do 3 flights. And so there's a lot of opportunities to come out and play. I was just going to drag this over. Hopefully, this ended up on somebody's screen. But that's my track and recovery vehicle. That's got a, hopefully somebody's seeing that, right? Doug?
Yes, I can see it.
Okay, great. Thanks.
It's
You-
delayed for me. I'm seeing the VLA.
Uh-huh. I have a question for you.
Sure.
What's a typical load? We haven't talked about what the students hang on there at all.
Well, and see, that's really a very interesting part of this. You know, we've flown everything from cockroaches to see if cockroaches will survive to space and back, and the answer is yes, they will. To CU aerospace students flew a payload to look at the color spectra of stars, and that was very interesting. So they had built this whole detector array that looked up and measured the luminosity of stars. We've flown payloads for national NOAA. Yeah, we did a NOAA project during the 2017 total eclipse through Wyoming. We built a 3-site DMR system with microwave links to cover 7,000 square miles of Wyoming because there wasn't any other way to get comms up there. And we flew 2 payloads for the National Weather Service that had to be in the middle of totality at 85,000 feet, which we hit. And those payloads weren't looking up. Those payloads were looking down. And what they wanted to know was if during totality, if clouds would form, which by the way, they did. We've flown everything from marshmallows, which come back as little rocks that you can hit with a hammer, because apparently all the moisture comes out of them, and when you lose all the atmosphere, they become very condensed. As I said, we've flown for middle school students. We flew cockroaches, and cockroaches do survive, which is a very interesting phenomena, and everything in between. We also fly our own stuff on a qualification flight once a year just to make sure it actually all is going to work. And we refer to that as our qual flight. So it's a fair amount of things going on there with students. And of course, you know, the students run cameras and video and all kinds of stuff. So, which is kind of an interesting end of it.
Hey, Mike,
Yes.
how many radios do you have in that vehicle? I mean, it looks like a DHS type of environment there with the lights and everything.
So the back here is what we refer to as the quiet part of the truck. And so the Starlink sits up there. And inside that enclosure, which is made by Pepwave. There's a Pepwave 5G LTE modem on AT&T and Verizon, and then it communicates through. They've licensed the API to talk to the Starlink, so the Starlink tells the Pepwave modem how many satellites, what its bandwidth is, and then the Pepwave will sit there and determine which is the best way to get data off the truck. And we use something called their Speed Fusion, which sends 3 simultaneous data feeds out of this thing to 3 different Pepwave servers, which put it all back together and give us a single feed that's all error corrected. These 4 antennas in the back are connected to a company called Doppler Systems DF setup. That's the old LTE antenna, and that's Garmin GPS puck. Now, in the front of the truck, there's a pile of stuff here. So this antenna right there is our APRS SDR antenna. That is a dual band Yaesu that we use. The reason we use dual band antennas, even if it's on a single band radio. So the front 2 here are DMR radios, but we're using on UHF, but we're using the dual band Larsons. And the reason was I didn't want to be changing antennas out. And every time you make a change up here, you have to recalibrate the direction finding system. So that kind of got us around some of that. So there are 2 FT 880s in the truck. There are 2 Motorola DMR radios, a 5550E and a 4550. There's a Motorola SLR 5700 repeater, DMR repeater in the truck that's linked to RM ham via the Starlink and the LTE modems. And so that comes out of that antenna right there. And even in low power, it was just too much. So there's a 20 dB, 50 watt inline pad on the output of that repeater just to knock the level down to the point where it wasn't getting into everything else in the truck. Part of the other problem, which was one of the reasons I was giving a discussion about vehicle power systems, is at idle with everything running in the truck, the current draw of the power system is 139 amps. So that got into a whole megillah about how do you make that run. This antenna here is a multi-band GPS antenna that looks at Glassnose, Galileo, US GPS, and 2 other systems. And that runs into a Raspberry Pi. And that turns it into basically 80 satellites, and gives us centimeter precision in terms of when we run WAS, we can have centimeter precision in terms of where we're located. That was just a rabbit hole that we decided that we were going to slide down one day to see if we could actually get it to do it, which, by the way, we were able to do it. But at the end of the day, we thought maybe we needed a little more adult supervision. I was going to see if I've got, well, that's what the Pepwave looks like. Come on, resolve the picture. I know you can do it. Yeah, okay.
I think Bill Miller had a question there earlier.
Sure.
Yeah.
Well, one of the things I was going to say, looking at the electronics package that you had up there, you're using a processor that not too many people are familiar with. And now you say you're working on a Raspberry Pi enabled device for the balloon. I'm kind of curious as to why why you have such a proprietary processor board. Why didn't they use a Raspberry Pi in the first place? Or was this done a long time ago?
It was done a long time ago, and I don't think we're actually talking about flying a Raspberry Pi. We're talking about using the Raspberry Pis for the track and recovery team to get the cost down.
Oh, can you fly a Raspberry Pi?
I I don't see why we couldn't, assuming that it can take the temperature. Oh yeah, and then occasionally things go wrong, like you break your truck and you have to have it towed out of Hugo, Colorado, and then you do track and recovery from the stop and the loaf and jug and at Hugo on one of the park benches. So, um, you know, never. If you got radios and coverage, it all works. But it was always fun to see the guy come out from AAA and pick up your ride and take it back to Elizabeth, Colorado to get it fixed. Yeah. So hang on. I was trying to find a picture of the repeater. Hang on. In the back of the truck. You'll have to excuse my, vacation pictures here. But somewhere I've got it.
Or are you using the repeater for the tracking teams
Yep.
to all use through?
Yep.
Okay.
And, um, we just didn't have enough build out of, repeaters on the Eastern Plains to make that work. Now, we put a repeater in out in Burlington. Oh, yeah, this is what kind of things look like after you run them through the dirt. Um, and we were talking about post-burst chaos damage. There you go. So that got smacked. And you can see it punched a hole right through the side of the package here. But getting back to comms, so a lot of places out there, you're just not going to get into any repeaters. And so even though that we put a RMHAM DMR UHF repeater out in Burlington along with a Colorado Connection VHF on a 480-foot stick, that only gives you about 40 miles of coverage with a 5-watt radio, DMR radio. And that was a kind of an interesting project because that 480-foot tower is an AM, so it's electrically hot. And so there was a whole bunch of work that had to be looked at to figure out how you're going to hang antennas off that AM tower without shorting it to ground, which we were able to figure out and get done. And that's a really nice site. And here's another kind of, you can see the flight string. That's the parachute. The flight string goes off way down to there. And that's outside of Haxon. And that was in November 18th of 2024.
They used to run repeaters on the balloon. Do you still do that?
Oh, we had a crossband repeater that we flew for a whole bunch of years. There's a wild story about that. In those days, so it was UHF, VHF,
Yeah.
and at altitude, you get about 400 miles of range.
Yeah. Big footprint.
Big footprint. But it had, oh, yeah, here we go. That's the Motorola in the back of the truck. In those days, does you guys and gals remember when they delivered newspapers to your home? And the Sunday papers always came in an orange plastic wrapper.
Yep.
Okay.
I do.
So the crossband repeater was wrapped,
I've stuffed a few of them.
right, in one of those orange Sunday paper plastic bags. And we were flying on a Sunday, and the crossband repeater was at the bottom of the flight string and it broke free and it dropped into a subdivision. And guess what? We're driving through the subdivision. It's on a Sunday, and everybody's front yard's got an orange wrapper with a Sunday paper in it. And we're trying to find our crossband repeater. So we drove around for about a half an hour. We just kept looking for somebody that had had two Sunday papers in the front yard, and then we found a couple of them that really did have two Sunday papers, but we were able to figure out where the crossband was. We haven't flown that in a number of years, but it's still around. We certainly could do it, but you know the problem, of course, is with the track and recovery teams, things are pretty hectic, and running crossband was always a little bit interesting in terms of waiting for it to flip back around, and you know, there's getting people trained up to do it was always a bit of a problem, and sometimes it didn't work, and sometimes your teams didn't know where you were. So this is the SLR 5700 that's in the back of the truck. The router board, Microtech router board, effectively is the VPN that takes the IP traffic off the SLR and sends it back and puts it into the RM-HAM network. And then we're provisioned using Seabridge for central and wide in this for the truck. And also central and wide, we have another setup just like this, except it uses an 8400 at the ground station. And it's a unique experience knowing that you can never quite outdrive your repeater coverage. We used a cheap Chinese duplexer here. And the reason we did that was because I needed the loss. I had too much power output, even in the low power mode of the Motorola repeater was still like 20 watts. And that was just way too much of it. And so, you know, a cheap Chinese repeater had, you know, a couple 3 dB of loss. And about every year I have to pull that out and retune it because it'll be kind of whacked out. But that still wasn't enough loss on the transmit side. So around the backside, there's a 20 dB inline pad, 20 watt inline 20 dB pad, just to knock that level down to the point where it wasn't getting into everything else. On this picture, you can see that's the Doppler Systems DF display, which is quite handy to see exactly where we think we're going with this. And you can see this thing is strapped down because we're blasting down some dirt road at 80 miles an hour. But you didn't hear that here. That's a bigger shot of the back of the Excursion. We have a cargo glide here that allows us to slide everything out. Otherwise, it became an archaeological dig to get stuff out of the back of the truck.
I take it you don't take this truck shopping for your wife.
No, not at all. This is a one-trick device. That's the alternator. I had that custom built by a guy in Detroit. It's a 250 amp alternator, and it's optimized to do 150 amp at idle, which means it'll saturate at typical highway speeds, but that's better to do it that way. We spend most of our time in the truck at idle, sitting by the side of the road, waiting for things to happen. And of course, the number one killer of alternators is heat. So where is this located? Right in the valley, where it's probably the hottest part in the truck. If I'm going to redo the whole electrical system, and I'm going to install a second alternator just to run the technical loads. It turned out to be a fool's errand to try to get all that stuff to work off from the vehicle power system. It was just a big lift, and it never quite worked that way that well. So
Yeah, I did. Mike, I'd remind this group, back in the early days of VOSS, DSES was using the dish up on Table Mountain in Boulder to do some of the tracking. And
Wow.
so in fact, I think the very first EOSS groups kind of sprang out of that group.
Well, there, we've been doing this for 30 years. I've only been around for 20.
Yeah, that was a long time ago. That was probably more than 20 years ago. Yeah.
Well, in the early days, you used LORAN, and that was interesting. The LORAN service. By the way, LORAN E is making a comeback, and that's because GPS spoofing has become such a major part of any sort of conflicts that LORAN E seems to be gaining a lot of favor, and countries can generate their own cost-effective LORAN E a lot cheaper than putting a bunch of satellites up in the air.
Yeah.
And then we also, we used to do DFing on a regular basis, and unfortunately, we haven't fortunately or unfortunately, we haven't done any DFing in a very long time, and I'm afraid that, we've lost a lot of the tribal knowledge of how to do DFing. And, we've had some talks about, doing a balloon flight and killing all of the beacons to, remember how to do direction finding. It's certainly up for discussion. But, now that we're running two APRS beacons, redundant APRS beacons, and we can also use ADSB off the ADSB to help us track things. We've got about 3 different ways to slay that dragon. So I just don't know if we're going to see a whole bunch of us with compasses and directional antennas, all getting a mark command from the alpha to make a measurement right now and report back in. It's a relatively challenging project, so we'll see. There's some other things I kind of forgot to cover on this project. One is on the way down, below 10,000 feet, ground winds become a large factor in what's going on. The problem is the ground weather at landing is going to be vastly different than the ground weather when we launched it. Could be 50, 60 miles away. So our team of software guys found this thing called CWOPS, which stands for, my brain just seized the minute I said it, Civilian Weather Observation Posts. And so there are a pile of folks out on the Eastern Plains that have put up weather stations and are certified by National Weather Service, and they link that data back into the National Weather Service. So below 10,000 feet, we take the CWOPS data and primarily wind direction and speed and put an algorithm against it to blend in the ground wind to improve our accuracy. And that's helped a lot, especially on really windy days out in the predicted landing area. So it's been interesting, and as somebody who's been around for 20 years, and I can tell you that we've seen a significant amount of changes, but it's still a blast. I like telling people it's the most fun you can have an amateur radio with your clothes on. And, it's kind of like doing a road rally where you make it up while you're going along, which is kind of exactly what we're doing here.
Well, that's amazing. Thank you very much, Mike. This is one of our most interesting presentations recently, and definitely there's a lot more technology in this thing than I ever imagined. I'm sure most of our listeners tonight have also think the same way. I mean, I just can't believe how much stuff you got done and what you do and how you do it. Last question for you, if you don't mind. Has any of these balloons ever hit an airplane?
Nope. And the reason for that is because we tell the FAA where we're going, and they route aircraft around us. And now with ADSB, if the if something happens where the FAA doesn't do it, the collision warning system in the aircraft is going to go off and tell them that they're on a collision course with a balloon that can't move. And well, it can't. We do not fly the balloon. It's up to the weather to fly that balloon. And uh, we were obviously watching with great interest that flight that ran into the weather balloon and broke its windshield. And for us, we have some things that are stuff that we're just not going to do, which is we don't fly stuff without the FAA knowing about it and providing tracking.
I was thinking about the small aircraft like Cessnas and those kind of things that don't fly that high anyway. They're probably way out of your bandwidth, but yeah, just thinking about it. That's all.
Well,
Yeah,
We
they-
provide a notice
ahead.
to airmen. We have a NOTAM, so all of the civilian pilots will know about our activity. And they track ADSB as well.
Yeah, there's a fair number of GA guys running ADSB because it's certainly a way to be safe. Uh, and dealing with the FAA can be, for lack of a better term, challenging. And we have to renew
Yeah.
our certificate every year. And
well,
we have like I said, a crew of people that deal with the FAA. I can't do it. It's like having bees in your head.
well, Mike, what about these micro balloons now, the ones that are
Yeah.
circling the Earth?
And Pico,
Pico
Yes.
balloons. Wait, can you say something about that and how that works?
Sure. Those are what we refer to as ZIF fills, right? So the amount of fill in those is really minor. Its whole job is to get a very light payload, which consists of 2 solar cells on a PC board, and the string is the antenna, for all lack of a better term. The ones we currently have up are running on 20-meter Whisper. And I was just trying to find Jim's email about it because I could probably pop up real-time tracking here.
And the whisper stands for what's that?
It's that digital.
it's weak signal processing reporting.
Position reporting, right?
Yeah.
Yeah.
And those things only transmit when they're in light. Okay, God, that's the wrong one of those.
Okay.
And
And these things are under the weight limit for the FAA to care about?
yep, they're like
Yep.
maybe a pound. I don't even know if they're a pound.
Payload is about 30 grams.
30 grams. Wow. And what kind of balloon do they use?
It's a plastic balloon, and it's what they refer to as a zero inflation. So it uh,
Initially, they used Mylar party balloons, but the ones that we fly are a bit more, bit better quality.
well, yeah,
And they don't pop. They stay inflated at altitude. What
Yep.
kind of altitude are they running as they go around the world?
well, they're
Well-
somewhere between 40 and 49,000 feet. And I'm about to drag a picture in here.
So they're out of FAA range, pretty much.
Yeah, they don't. Hang on. All right, let me see if I can drag this in here.
I'm real curious about this because that sounds like something my grandkids would love to do.
Well, and we launched. Hang on. There we go.
Let's, I was talking to another club society member about doing just that. So let's talk about that.
Yeah, Ted's posted a track on the web on the chat. Thanks, Ted.
Yep.
And I
here's
think
the real-time one up.
okay, there's where it is out in the middle of the ocean.
Yeah, EOSS 2 updated 3 hours and 8 minutes ago. 4 was updated 5 minutes ago. And 3 we haven't heard from in 22 days. and it might have gotten shot down over North Korea for all I know. But
Don't want to fly it over Texas.
yeah, I'm telling you. So so four is running 48,000 feet, and
Okay, there it is.
two is at 46,000 feet, 80 miles an hour. Hang on, let me look at this one.
And so you said one of these has been around 10 times?
11.
11 times. Remarkable.
Yeah, it's very interesting. And Jim Langsted's the guru of getting this done. And he's developed and figured out how you get it all to work exactly the right way. And he solders up he buys a kit that's got the PC board and he solders it all up and puts the two little microscopic solar cells on it, and then he orders up the balloon, and our gas passer, Larry Noble, knows just the right amount of fill, and the thing goes up, and it looks like it's got nothing in it, right? The balloon is very limp, but that's what you need because at 48,000 feet, it's full enough, and it's not going to go up any higher, and it just circles the earth. And those Mylar balloons hold up really well, especially under the intense ultraviolet light that you get up there. Because remember, the Earth atmosphere filters out a lot of the UV. That was going 92 knots. Hang on, center zoom info.
So I'm wondering, is there some central repository or where do you get the kit? I mean, is there somebody that sells this or how does
Yep.
that work?
There's a guy that sells those kits. What's his name? Brown, last name. Yeah, Bill Brown sells the kit, and then you order the balloon from Amazon. I think that balloon's like $7 or $8. The kit's the most expensive part of it, and off you
Bill
go.
Brown's call sign is WB8ELK.
BLK Baker.
Elk. Echo
Oh, ELK.
Lincoln.
ELK. Okay. Elk.
Yeah.
Okay. WB8 elk.
And so on this on EOS S2 here, you can see that it's got bus voltage is 4.5 volts. It's in sunlight. Altitude's 46,000, and it's 80 miles an hour. And last time we heard from was 3 hours ago because it's out in the middle of the ocean and it's running 20 meters whisper. And 4 is on 17 meters whisper, and it's got 4 volts on the bus.
Huh.
Well, excuse me, guys. I gotta mute the mic here.
So it looks like these things just burst transmit like once an hour or something, or so these conserve power.
Yeah, it's there's no battery on those things, so they only transmit when there's sunlight to hold the weight down.
Yeah.
And we can certainly organize. Jim Langsted's our guru for pico balloons, and we can certainly organize give you guys a talk.
That's very cool.
Excuse me.
Maybe we could do one for the open house in the spring or in the fall.
I don't know. We got plenty to do. Unless we get one of your student groups to do it, Doug.
That's it.
There you go.
It might be fun to have. It might be fun to have a little 1420 transmitter on it.
Yep.
Well, the great thing about the Whisper is it reports in through a network of 20 meters, several different, but they all report in through the network, and that's how you get this track.
17 meter,
or 20,
or 20 meters, That's a constant. It's called a constant pressure balloon because by the time it gets to altitude, it reaches the altitude where it's in balance.
Yeah.
And it can't get any bigger. So it's bounded, and the altitude is set by how much gas you put in at the beginning. So the altitude is roughly set.
Yeah,
They've been used in meteorology for a long time.
very cool.
Yeah, and like I said, it took a couple of these before our fill team, our gas passers, really kind of understood. You develop a feel for doing this, right?
Yep.
Uh-huh.
And this was well outside of the how many, what are we going to lift? 30 pounds? No, right? This is a couple of ounces. So it was kind of an adjustment for the gas passing team, as it were. And they developed some fill techniques to make it all make sense. And I was just trying to see if I had some images from the launch. Hang on. Because it doesn't look right when you take a look at it. You're like, this is wrong.
And I guess it uses a Pi Pico, which is a microcontroller, real low power, underpowered processor, but you don't need much to do this.
Yeah, you'd have to talk to Jim about that. He's the
Well, I think, are you
resident
referring
guru.
to the IEEE article, Bill?
Yeah.
That's a different transmitter, and that was a different process. What Bill Brown does, he makes his own. He designed the transmitter, and that's the one that we are using. And then there's another guy in Tasmania who sells a transmitter. But that IEEE article was a. Well, I'm glad it flew. It's not. It that was a really different build and unlikely to survive as well as these guys.
Oh, okay.
But it was that was a good article. But Bill Brown's kind of been doing this for 20 years. He's kind of the really responsible for the popularity of the Pika balloons in the nationally and internationally.
Well, we'll have to look at maybe bringing on Mr. Langston and maybe Mr. Brown sometime. See if they're interested in chatting with us.
I suspect they probably would. And so this VLA image, I'll just tell you the quick story of this. I was on spring break with my son, and we decided to go down to New Mexico, and we were going to do something that got canceled because it was the wrong time of the year to be there to do it. And we kept seeing these signs for the very large array, and I was like, hey, let's go drive out there and look around. So we drove out there, and they had all the dishes in on the close setup because they can change the aperture based on where these things are pointed, which I'm sure you all know. So I pull over to the side of the road and I light up the truck with the light bar and we get out and take a bunch of pictures. And this guy pulls up and he goes, hey, are you an amateur radio guy? And I was like, yeah. Well, this guy was one of the maintenance techs down there and he was an amateur radio guy. And he said, well, can you be down here at 8 a.m. tomorrow? I'll give you a tour. So anyway, we got down there at 8. We were staying at Socorro, so that was a 90-minute drive. And we got a tour of the doghouse in the inside of one of these, and then we were actually able to get up and climb in on the dish that was up for maintenance. So, it's one of those things where your amateur radio license, kind of gives you an in to get into places that, mortals usually can't get into. So that's my VLA story.
Yeah.
Sometimes people think we're actually smart.
Yeah, well, sometimes you just stumble into stuff,
You did better than I did, and I've been down there for SARA conferences twice and given presentations twice and never got to go inside of one. So we got tours of the outside and the control room and everything, but never got to go inside of one. So that's you did better.
Well, it's interesting because they cryogenically cool all the receivers, and
Yep.
the doghouse down there is pretty chilly, and uh, that was kind of and Carrier makes all the cryogenic cooling stuff for that, which I had no idea that Carrier, who I thought just made air conditioning for homes, did that kind of work,
Oh yeah.
and that was fascinating stuff. And of course, we turned all of our transmitter stuff off. For miles around there, like turn off all your radio stuff. You're going to interfere with us. So of course we did. And but yeah, somewhere I've got a whole series of pictures from that adventure, including us inside the dish. Um, but yeah, that an iconic shot and just kind of fun. But
Hmm.
yeah, and
Good.
I've been subsequently down there, and the guy that I knew on that team retired, and I've never gotten close enough to another time again. So it was just one of those happenstance things. But had I not parked by the side of the road and had all the lights going and all the antennas on the truck, it wouldn't have happened.
Thanks, Mike, for all your effort here, and it's really looks great. Thanks for putting on this presentation for us, and hopefully at some point maybe you come down and visit us in Haswell.
Yeah, I'd
We're
love to do it. My day job is last year I did 140 nights in hotel rooms last year. And like I said, I flew back in from LAX this morning. So my schedule is usually pretty full, but if you guys can let me know when you're going to do your big thing down there, I try to get it on the calendar and maybe make
we
it
do it.
down there.
Our open house is usually around the end of September and or early October, depending upon where the moon is. Yeah, because we like to show people what they sound like off the moon.
Aren't you guys trying to do a big bounce off from Mars
Well,
or
no, that's Venus.
Venus?
Yeah, it's only what 56 million miles away or something. Anyway, it's actually pretty close.
Well,
But
but the round trip's got to be how long?
4.5 minutes, a little more. So it's a long echo, and we need a lot of signal processing to hear ourselves, and that part is most interesting how they do that. But
What do you think the
we
path loss?
345 dB. So it's a little hard. We need a lot of power. This year we're going to try it on 2304 as well as maybe 1296 again. The Venus it's a slow pass, so we have a couple of weeks to do this, and we'll probably be doing that in October. October the 23rd, I think, is the date when it's actually closest to us, but we'll probably be doing it before and after that as it goes past the sun.
So we can't
And
shoot into the sun.
not no, it's not advisable these days.
Yeah, they proved that 2 weekends ago.
Yeah, it's the first time I've ever seen something actually disintegrate.
But we know how to make hot dogs at the next open house.
Yeah, we have a great solar furnace there. And anyway, we're also going to be doing some work with the Artemis 2 manned mission around the moon when they hopefully going to launch again in April, and we'll be tracking their carrier signal from Earth with our dish.
Cool. How much gain is the dish at the frequency you're going to use to try to hit Venus?
Approximately 51 to 52 dB, something like that.
I'm assuming you're going to run a whole kilowatt into it, right?
Well, no. Oh, you mean into Venus? Yeah, but
Yeah, yeah.
well, at least that. We'll try to get maximum, but it's going to require some engineering, and we're going to be doing that this summer. So it should be fun.
I had at one time I was I had a C-band uplink feeding a signal from Denver to Vail, to a station in Vail, and we had a 60 dB Proline dish and a 10-watt buck feeding it. And one day we had a micro burst right over the uplink, and the automatic power system cranked the buck up to 10 watts, and we still couldn't make the satellite. And the ERP in that was, let's see, 60 dB times 10.
It's a lot.
It was a lot, and we couldn't burn through that. I figured I'd go out and see a bunch of medium rare birds around the base of the dish, but apparently
We're going to be running megawatts, so you probably don't want to be in front of our dish when we try this. So
you're going to need megawatts with a 300 some dB path loss. So
Yeah, we're over 20 dB below the noise floor. So on the receive signal. So you got to do some signal processing to get it up.
I was going to say there's a lot of signal processing.
yeah, well, we've got the computers and we got the guys who can do it.
Well, do me a favor and somebody shoot me those dates, please, and I'll put them on the calendar. And if I'm not running around doing my
Yep.
day gig, I'll try to be down there. And is there any civilization near there?
No.
Oh yeah, there's a place called Eads, which is about 20 minutes away, and they have a nice hotel called the Cobblestone Inn, and we have a special rate there.
Okay.
So
So
if
just as long as there's no chalk outline of a body and crime scene tape around the lobby, I'm good. So
yeah,
I think
I'm
they
sure
removed that.
they got rid of they got the chalk outline of the body out of the carpet.
Yeah, I haven't seen it for a while.
Oh man, you guys, I was about to say, there's just as long as it's, not the Bates Motel and you don't get the theme song
no,
from
it's not the Bates Hotel.
Psycho
We get-
or-
Yeah, if Mike
You-
spent 150 days in hotels every year, then he's probably seen that a few times.
Yeah, I'm sure.
yeah, it's
Well, thanks, Mike, and I'll be in touch, and Doug will be in touch and giving you the dates as well, because Doug will know everything.
Doug knows everything.
Everything.
Oh, yeah.
Yes, he's the smart. Thanks, everybody, and
Thank you so much.
All right, thanks very much, Mike.
this will be on Zoom, by the way, or not Zoom, YouTube. We have a YouTube channel for Deep Space Exploration Society, so you'll probably be on there later this week.
Well, I'm again, thank you guys for inviting me to give this talk, and I apologize for being a little sniffly tonight, but
Thanks.
glad it all worked. So thank you guys very much. Appreciate it.
Our
Thank
pleasure.
you, Meg.
Take care.
Time for hot lemon and blackjack.
Oh, that's hilarious. That is hilarious. All right.
All right.
Thanks, everybody.
All right, thank you.
Best for all. Take care, guys.